All right, in this section we're going to talk about trace, which is a number that is extracted from a matrix. And this number gives us some information about the matrix, and we'll be seeing trace somewhat later as well. But there's a lot of interesting properties of this number. All right, the trace of a matrix is simply the sum of the entries on the diagonal. The trace can only be defined for a square matrix. All right, so in this case, the sum of the diagonal entries, 2 plus 5 plus 8, gives us 15. Right. Now, it turns out that the trace of a matrix does not depend on the order in which you multiply the matrices. Okay, so if I take the trace of a product matrix, the trace of Mn is equal to the trace of Nm. And you can prove that using this summation notation. All right. Here it's kind of abbreviated, stripped down summation notation. This is the summation over the index L of MIL times NLJ. Remember, the L here is the row index, the L here is the column index. And of course, this will be L equals 1 to N, say. All right. Now, if I take the trace is the sum of the diagonal entries. Diagonal entry means that the row index and the column index are the same. So I'm looking at the row index and the column index of the result. The row index is this I up here, and the column index is this J down here. Right. So I'm only looking at entries where the row index equals the column index, so I can set these two equal to each other, can call them both I, and then I sum over I. Okay, so here I have MIL, MNLI. Okay. Now, here you could see that I could just switch the I's and the L's, or I could reverse the order of these two and just unpack it, and I find out that I get the trace of Nm. I'm just exchanging the roles of I and L. Here I is the summation index in the product, and then this L is the summation at the end. All right. So there's a video to explain the proof also. Here's an example to show that it's true. It's also true that the trace of a matrix is equal to the trace of its transpose. That's pretty easy to see because the transpose doesn't change the diagonal at all. And that takes us through to the end of trace.